Hello again, everybody. Let's take a look at solving a system of linear equations, 3 equations and 3 unknowns in this specific case. So you'll see here I've got a system of 3 equations, 3 unknowns. The unknowns are x, y, and z, and all of them are taken to the first power. So that is indeed a system of 3 equations and 3 linear equations and 3 unknowns. And I want to take advantage of some of the stuff that we've talked about in earlier videos on matrices. And so what I want to do is I'm going to remind you that I can take a 3 by 3 matrix, which would be 3, negative 2, 2, negative 1, 2, negative 4, 4, negative 3, negative 2. This matrix, which is referred to as the coefficients matrix, and I multiply that by the variables x, y, and z. And this will equal the constants on the right-hand side, which is negative 18, 16, negative 21. And again, this is the constants matrix. So what I want to do is I want to solve for x, y, and z. And let's think about how we've done this in the past. If I had, again, I've talked about this earlier, but if I had 3x equals 21 and I wanted to solve that, I would divide both sides by 3. And so I'd get x equal to 7. Or I would take 3 inverse times 3x on the left side and 3 inverse times 21 on the right, which is 1x. And that's just x, and that's equal to 1/3 times 21, which is 21 over 3, which is 7. So I get the same answer either way. So I want to do this in a couple of different formats. And the first format I do will be to utilize my calculator, which is over here on the right-hand side of the screen. And I'm going to take advantage of that. And what I'm going to do is I'm going to feed into the calculator the coefficients matrix and the constants matrix. So I'm going to start with the constants matrix. Now technically this should be a vertical matrix, 3 by 1, but the HP will allow me to utilize its capabilities and put this into a horizontal matrix, which is also a vector. So on the HP it's a vector. That's not technically a vector. So there's negative 18, and then I hit the space button, and then 16, space button, and then 21, and that's negative, so hit the plus minus. And so I hit that, and I hit enter. And so I want to kind of keep this, so I'm going to go ahead and save this under the constants variable. So I'm going to hit the tick mark, and then I'll hit the alpha key twice to lock it, and then I'll just hit C. So let's call it CN. And store it. Okay, so you can see CN up in here, and I can bring that back. Okay, then let's go into the matrix writer. So I hit the blue shift, and then up here above the enter button, you'll see matrix. And I've got 3, space 2, change the sign, space 2, enter that, hit the down arrow, it automatically is set up to go to the far left-hand side. 1, change the sign, space 2, space 4, change the sign, and finally 4, space negative 3, change that sign, and 2, change the sign to make it negative 2. And then I hit enter, and there's that matrix, and let's go ahead and store that. So I'm just going to call this so tick mark, alpha, COE for coefficients, undo the alpha, and store it. Okay, now technically what I should do is I should take 3, negative 1, 4, negative 2, 2, negative 3, 2, negative 4, negative 2, and create an inverse, and then multiply that by 3, negative 2, 2, negative 1, 2, negative 4, 4, negative 3, negative 2, x, y, and z. And this will create 1, 0, 0, 0, 1, 0, 0, 0, 1, the identity matrix, times x, y, and z, which will be x, y, and z. And then I set that equal to this. Of course, what I want to do really is take, remember, whatever I do to the left, I have to do to the right. So I'm going to take 3, negative 1, 4, negative 2, 2, negative 3, 2, negative 4, negative 2, inverse, and I'm going to multiply that by negative 18, 16, negative 21. And we'll actually do this, and this will give me my values. We'll do that here in just a minute, using the inverse. Well, actually, let's do that now. Okay, so what I want to do, let's get rid of that. So I'm going to take the coefficients matrix. I need to invert it, so I'm just going to hit the 1 over x button here. And then I'm going to take the constants matrix, and I'm going to multiply it. And so you can see that I get negative 2, 5, negative 1, and there's some round off errors in there. That's just the programming can only go to so many significant digits. But that's going to equal x, y, and z. And so the solution to this system of equations is x equals negative 2, y equals 5, and z equals negative 1. But the beauty of the HP calculator, this device is created by engineers and pretty much made for engineers, is they're going to make my life really simple. I'm just going to take the constants matrix and then the coefficients matrix, and I just hit divide. And you can see the same answers, negative 2, 5, negative 1, appear up on the stack. And what happened with the original one is I had the inverse matrix, and when I created that, there was some round off error. This just divides out. Is that a mathematically legal move? No. But the engineers created the calculator to do it because they know, and the calculator knows in this case, what it is we're trying to do. So even though it's not a legal move, what we're doing is we're taking negative 18, 16, negative 21, and I'm dividing by 3, negative 2, 2, negative 1, 2, negative 4, 4, negative 3, negative 2. All right, so let me show that to you one more time. I take the constants matrix, put it on the stack, take the coefficients matrix, put it on the stack, and I just hit the divide by button over here on the far right. And there's my values for x, y, and z. So again, x equals negative 2, y equals 5, and z equals negative 1. And that's the solution. This right here is the solution to this system of equations right there. Okay, so we've done that on the calculator. Let's do it on Excel. And so I'm going to create the coefficients matrix here in Excel. So my top row is 3, negative 2, and 2. And then my second row is negative 1, 2, and negative 4. And then finally my bottom row is 4, negative 3, negative 2. That's my constant, or my coefficients. And so then the constants matrix, that now Excel doesn't understand what the HP did, so I need to put this in as a column matrix, a 3 by 1. So that's negative 18, 16, and negative 21. All right, so here's my coefficients matrix. I'm going to make this look a little nicer. I'm going to hit merge and center after highlighting all 3 of those cells, and you can see it makes one big cell with coefficients in the middle. All right, and I think I want to just make this look nicer again. I'm going to center justify everything here. I just think it looks better. Okay, now what I need is the inverse coefficients matrix. So inverse coefficients, if I can spell. And again, I'm going to center that out. Oops. There we go. Now Excel can create this inverse matrix for me. There is a function in Excel called matrix inverse. It's actually called M inverse. What I need to do is I need to create a 3 by 3. So I'm going to highlight 3 by 3, starting in the upper left-hand corner. And then I enter equal sign. You'll see that up here. I enter the equal sign and then M inverse. Open the parentheses. And you can see before I did that, it says returns the inverse matrix for the matrix stored in the array. So I need to highlight then this matrix up here, and then close my parentheses. And then in order to get this to work in Excel, I hit Control-Shift-Enter. So any of the matrix operations require Control-Shift-Enter. Hit the Control and hold it, hit the Shift button, and then hold it, and then hit the Enter key, and it will come out. And then what I want to do is I want to take this matrix and multiply it by that matrix. And so that's going to require matrix multiplication. And so let's just put answers over here. And so I'm going to create a 3 by 1 matrix. So I highlight all of those. And then I hit equal sign. Matrix multiplication is M-U-L-T. And then you can see it says returns the matrix product of 2 arrays. So I open my parentheses, array number 1, it's waiting for array number 1. That's this guy right here. Comma, and now it's waiting for array number 2, which we'll see right there. Close my parentheses, again, Control, Shift, and Enter. And there's the solution to the problem. So this is the answer for x equals, y equals, and z equals. And let's just center everybody so it looks better. Actually, it might look nice here if I right justify that row or column and left justify that column. Okay, and there's your answers right there. We'll just highlight that cell. Okay, and that's how you multiply the matrices and the inverse in Excel, how we solve for the system of equations. All right, I hope that is helpful. If you have any questions, please leave them in the comments below. Thank you.